I'm here today with Dr. Matthews and Dr. Pitts to present the Burst Pre-Professional panel. So they'll be giving some insight into their journey and exactly where they are now and where they've come from. So please welcome them and welcome them with your questions at the end. Please don't have any homework or distractions out. They're here for your time. So the sign-in will be at the end of the workshop. So make sure to wait till the end. And then they will give their presentations and we will ask some questions. And then at the end, questions will be open for anyone. Yeah, so this is Dr. Pitts. Dr. Pitts is a genetics lab coordinator, and Dr. Matthews is a clinical professor and pre-medical advisor for the Honors College. Awesome. So if Dr. Pitts, you would like to take it away with your presentation, I'll stop sharing my screen and I'll give you the sharing ability.
Okay. Okay, I will share mine in a few minutes. Okay, can you hear me?
Yeah.
Yes. Okay, I thought I'd tell you my story first, and then I just have a couple of slides to go through I presume you all know, since you're interested in research, a lot of this information, but I thought I would bring it up anyway. So I've been at Baylor since 2017, I guess. And I thought I would start from the beginning because part of this is I thought it'd be interesting for you to hear my story so that you are open to your own story, because the journey for me is not what I expected. In high school, I think we all can agree that we all liked science, right? Science, math, and I loved biology. And so I went to college thinking I would go to medical school. And I remember my genetics professor actually asking students if they were interested in doing research. And I thought, oh, why not? So I went to talk to him and he actually placed me in a research lab. And, I had a great experience. I don't know that I really understood what I was doing, but it did help me get into graduate school, I think. I remember I did a fellowship at my high school, and I don't even know when it was that I had that little switch that flipped in my brain thinking, okay, what do I want to do? Do I really want to go to medical school? I really did not know. And I still remember walking in the rain really early in the morning to take the GRE on standby. And then I remember applying to one graduate school, and I remember getting into that one graduate school. And I remember it was a PhD program, and my parents said, you're going to get paid for more education. And that's one of the things that I do love about PhD programs, I will say, is that especially in the sciences, we're really blessed. I think in a lot of other programs, PhDs are not paid for. But in the sciences, you are. And I thought, okay, I'm going to go to graduate school. Now, I don't think that's for everybody. I think now you should really make a conscious decision, because I really didn't know what I was getting into. I did not know that once you spent all those years doing science, you would be having to do a postdoctorate after that. And I did enjoy my experience, but I got a little bit burned out in graduate school. I can tell you about the research I did sometime, but I've always been glad that I went to graduate school. But after I got my PhD, I decided I really didn't want to do science anymore. So I copy edited medical papers. And then I remember I met this man who worked on an insect hormone. I had worked on a plant hormone in plants in Arabidopsis. And I studied auxin, AUXIN. And do y'all know about auxin? So let me tell you a tiny bit about it. So I noticed on my son's AP biology exam that he will be taking, he's a junior in high school right now, there's something about what is the hormone that causes plants to bend toward light. And it is actually the hormone that moves over to the shady side and causes cell elongation. And also, little example, for example, strawberries, those little achenes on those little seed lookings on the outside of a strawberry, if you take those off, the strawberry will no longer grow. But if you give it an exogenous source of auxin, it will start growing again. So it's really important in cell development and elongation. And I went to listen to some music. My husband actually loves music, and he was singing. And so I was sitting in this restaurant area with this man, and he said, "Oh, I heard you have your PhD, you studied, what did you study?" And I said, "I studied auxin." He said, "Oh, like the big animal?" I said, "No, like the plant hormone." And he said, "Oh, I work on an insect hormone." And so we started talking, and this was in Nashville, Tennessee. So I got my PhD at Indiana University and moved to Nashville, Tennessee to be with my husband. And I went out of town and I came back, and my husband said, "You were just offered a part-time postdoctoral position." And Willie Honegger, who is probably one of my favorite people in the world, made me love science again. We studied bursicon, and he knew I wanted to work part-time because I did not enjoy, I was copy editing medical papers and I didn't want to do science. Well, he made me just fall in love with science again. And he was not set up for molecular biology. So we worked together on molecular biology. We actually cloned the bursicon gene. And this was back before things were easy. I think Dr. Matthews knows about that, where it's, it just took a lot of time. But bursicon is a really interesting hormone that, sorry, I'm in a meeting. Bursicon is a really interesting hormone in that when an insect molts, every time it molts, it comes out white. Have you ever seen a white-looking insect? Okay, they're really soft and they're white. And when they emerge, they darken and they harden their cuticle and they have to expand their wings. And that's what bursicon is involved in. So it was really, really exciting for us. And there are a lot of different experiments we did. But I want to backtrack and say that, well, first of all, so I worked with Dr. Honegger until he retired. So I did my postdoctorate with him at Vanderbilt University, and I continued working at Vanderbilt until he kept telling me he was going to retire. So I kept saying to my husband, "I'm going to keep working," even though we had a child. I was like, I want to keep working with him until he retires. So I did. And I stayed home for about 12 years with our children. And I homeschooled them. I homeschooled our son through 3rd and our daughter through 6th. And we moved here when she was going into 6th. And so the backtracking is when I went to graduate school, one of the reasons it was so hard for me was I had to teach genetics lab, which is ironic, right? So I'm sorry, just one second. I'm in a meeting. You need a key? Here, you can slide it back under my door. Sorry, I have a key to the room next door, so somebody. So I taught the genetics lab at Indiana University. I was a first-year graduate student teaching juniors and seniors, something that I had never taken in college. It was really, really hard. And I had also only read one scientific paper in my life. So I love that you all are reading scientific papers and that you have journals. It is fantastic. Any experience that you can get. So when we moved so my husband is a mosquito biologist. He's basically an entomologist, and he's here at Baylor. And we always thought it would be fun if he ever had his own lab for me to be his lab technician. So when we moved here, I said, "Oh, I can homeschool and work for you part-time, set up your lab, and it would be fun getting back into experiments." And so I did, and I knew the genetics lab position was coming available, but I did not want to go full-time in a position because I knew my daughter was going to school. And I thought I could work for my husband part-time and finally, make dinner for our family and do things that I've, actually start their baby books. Anyway, but I feel like God had another plan because the person who they hired 2 weeks before school started in 2018, I still remember getting a phone call from the chair of the department that the lab coordinator decided not to come. And would I please consider being the lab coordinator? And so I told the people in my husband's lab, you know, I actually think it would be really fun, and God actually prepared me to do that, but there is no way I will ever teach the lecture portion of the genetics lab. And Dr. Minke was teaching it at the time. So that fall I taught it. And then in the spring, I taught it again. And she said, will you please just apply for the full time and you can do the lecturing and all that. And I said, okay, so here I am. So at the very end of my talk, I want to give a plug about the genetics lab because it's the best lab at Baylor. It really is, not because I teach it, but because of what you learn, okay? So I just want to go through a few things, and you are more than welcome to interrupt me if you want, but I do want to share my screen just really quickly, and I'll only talk for maybe 5 more minutes because I don't want to take up the time.
Yeah, that sounds great.
What?
That sounds great, yeah.
Okay, 5 more minutes? Okay. Let's see. Okay, y'all know about the Career Center, right? Okay. And do you all know about the Friday seminars from 2:30 to 3:45? So every Friday, right now they're by Zoom, via Zoom, but the biology department has these seminars. What you may not know is that you can get credit. It's a 1 credit hour class where you go, it's called scientific communication, okay? So I really want you all to know about that. And it's really, I think from 2:30 to 3:45, you sit and you watch the lecture. If you're really interested in research, I recommend reading about the person who's giving the seminar first and then going to listen to them. But I think it's great if you're in graduate school. And you all know about Baylor Eureka, right? Okay. So I love that because it actually tells you every place, every single place in the sciences and the humanities, and it gives complete descriptions. I kept this on here. Sorry, I'm actually pointing to the different one. I liked it because it's spelled G-R-O-S. I was just like, gross. Anyway, so if you're interested in research, I don't know how many of you are doing research, but you want to find the research, you want to familiarize yourself with it so that you can, and what I do is I actually Google the faculty person's name and then the word Baylor and read everything you can about them, learn about the students in the labs. A lot of times that's up there. Go to the outside of their office and look at posters and then schedule a meeting. You can talk to the students in the lab or and then the faculty member. And then you could actually apply for undergraduate research. So it was Bio 3V90, now it's Bio 3V9R for research. And you actually have to have a mentor to be able to sign up for that. But I am more than happy to talk to you about that. One more thing I want to point out is, y'all know about the Mayborn Museum. I don't know if you know that there's a portal to the public where what you can do is you can look up Mayborn Museum, portal to the public, and there's a half-day workshop that you can go to, and they will allow you after that to demonstrate research, and you can choose what you want to do. Like for me, I love showing little kids a centrifuge and a vortex and letting them see the difference between, you know, spinning things and then making them go really fast. And so, but you can teach kids a little something, and I think it's great because it's only you have to go to 2 events per semester, and it's like just an hour or 2. So look that up. I just want to make sure everybody knows about the Baylor Counseling Center, right? You all know about that. You all are in a very sort of stressful, I feel like you're in a really stressful, wonderful, but a little bit stressful major here at Baylor. So one quick thing too about genetics. I was asked to talk about how to study for genetics, and I just want to say that, of course, every professor is different. I've heard that Dr. Miles's quizzes are really, really hard, but definitely do it with active learning. Make sure you look at the syllabus. I know we just kind of put it aside, but before you write to your professor, just make sure you're asking the right questions. Read the chapter, especially with Dr. Miles, and then those objectives with Dr. Minke. I know that if you can go through those objectives and just explain them to somebody, we always talk about that. Do it actively and then always do her practice problems. Just a quick plug. Do I have just a minute, Parker, on this? This is the genetics lab in a nutshell, okay? And what's so amazing about it is you do a 5-week project on subcloning, and we run through all this. I'm not going to go through it because you can learn on there, but we learn about the lac-operon and all of this stuff. If anybody is deciding to go to dental school or medical school, this stuff is on the MCAT. And I've actually adapted some of my questions from MCAT questions. It's only 1 credit hour. And I know I just gave a shameless plug, but I want to tell you too, you learn about PCR. And I always, like, whenever I give my lectures, I like to tell students, you know, if somebody didn't notice that, and you may not have learned about polymerase chain reaction yet, but that's what they're using to identify the coronavirus, right? But they're using RT-PCR, which is reverse transcription. And if a scientist had not discovered that mRNA has a poly A tail, we would not be able to do reverse transcription and then polymerase chain reaction. And there's so many things I like to point out. So what I want to say with your studies is try to put 2 and 2 together. You know, like take all of your disciplines and bring them together. And I didn't learn to do that until I was older. I always wish I'd gone to office hours. I always wish I'd gone to the career center, because if you can go to office hours and talk to your professors, you need to make connections, because guess who writes letters for you and has to get to know you, and make connections with each other, which is great, because then some of you will help each other find a job. So, and after Dr. Matthews goes, if I have time, I'm going to do one more little thing. So I will turn it over.
Thank you so much, Dr. Pitts.
Yes.
We really appreciate you having all these like practical applications for us to like actually get involved with research. And so we definitely appreciate that. And hopefully we do have more time at the end for you to give us some insight into something else. Okay, now for Dr. Matthews. Thank you so much, Dr. Matthews.
All right, thank you, Parker, and hello, everyone. So let me see if I can share my screen here.
Let me mute. And I'm so glad I'm not following in your footsteps.
Well, you haven't seen what I'm talking about yet.
Oh, I know you. I know all about you.
All right, so I don't know. Oh, my screen just froze. Can everyone hear me still? Okay, there we go. Okay, so I tell you what I'm going to talk about tonight is the practice of medicine in space. But first of all, let me tell you my story. So I began right where you are. I was a biology pre-healthcare BA student at Baylor University. I'm Baylor class of 92. I went on to medical school at Baylor College of Medicine, did the health profession scholarship program with the Air Force to pay for medical school. Thought that I was going to spend 4 years and get out and go into regular practice. And I found the greatest life I could possibly find as an aerospace medicine specialist in the Air Force. So I can talk all about that with you if you want to come by the office or another time here with our discussion. But essentially, my mentor here at Baylor, Dr. Bill Hillis, which many of you probably have heard about from the Hillis Scholars, he was my mentor, and he directed me and pushed me towards the Air Force. And so he changed my life. And so I have now come back to Baylor after a career in the Air Force for 28 years to be Bill Hillis to a new generation of students at Baylor, to help you go on and live meaningful lives. Hopefully in medicine, but if not, in whatever you choose to do. So I retired about a year ago as the first Surgeon General of the U.S. Space Force. And now I've come back as a clinical professor here at Baylor, and I'm mentoring pre-med students and teaching pre-medical courses. Courses I've taught so far are history of medicine, teach a couple of seminars for the Honors College, but my favorite course is pathophysiology. It is the hardest course you will ever take if you come take that with me your senior year. But it is so worth it because it's the beginning of medical school. And pertaining to what I'm going to talk about tonight, this coming spring, I'm going to introduce a new course called Physiology of Austere Environments, an Introduction to Air and Space Medicine. So if you want to learn what we're going to talk about right now, then you can come take my class. It's going to be awesome. Okay, practice of medicine in space. Here we go. So for the last 60 years, we've practiced space medicine through NASA, through other countries. But that space medicine that we've done has been involved with the selection of astronauts, which are the healthiest group of people on the face of the Earth by definition. And then we prepare them physically to go to space. And then we monitor them and manage them medically while they're on orbit. But once they get there, there's not a lot we can do because we don't have physicians in space. Actually, we do. We have doctors that are astronauts, but they don't go to space in a doctor's role. So we basically have to talk to them from the ground to figure out what's going on with them. Well, that's okay for orbit around the Earth. But what happens when we start going further, when we go to the moon, when we go to Mars? We're going to have to be able to do more than what we've done for these last 60 years. So that's where we're going. We are going to Mars. We're going to Mars. It's happening. It's going to happen. Okay. And it's going to happen soon. And many organizations are planning to do this. We've got SpaceX. You've probably heard the rumble of the rocket test facility out in McGregor. Boeing is planning to do this. China is going to Mars. Russia is planning this. The European Space Agency is planning this. Everybody's planning to go to Mars. Oh, and NASA is also planning to go to Mars. So NASA's going to Mars. And the first step in that is the Artemis lunar program. And the Artemis lunar program involves operations in cislunar space. So cislunar space is the surface of the moon that we can see from Earth and all of the space between that surface and here on Earth. So the part of the space between there. It's kind of our celestial playground for right now. We're going to build a lunar gateway orbiter, which is an orbiting space station that will circle the moon. And that's the location where we're going to put together and launch the Mars Orion mission. And so our cislunar space operations and eventually our operations on the surface of the moon is practice for when we go to Mars. Because we got to figure out how we're going to do things before we take a 6 to 9 month trip to Mars to figure it out there. So we'll assemble and launch the Orion mission from the Lunar Gateway. It will launch. It'll do 2 slingshot orbits around the moon and then head to Mars. So it's about a 6 to 9 month one-way trip from the moon to Mars. So once we get there, we will initially set up a semi-permanent and eventually a permanent presence on Mars. Now, if you think I'm talking pie in the sky, pun intended, and kind of the science fiction stuff, let me tell you that 3 years ago, I took a trip down to Kennedy Space Center at the Space Coast in Florida, down near Cape Canaveral. And I went to the Boeing build facility with the director of Kennedy Space Center. And I climbed a scaffolding ladder and I stuck my head inside the capsule, the Orion landing capsule that will take the first humans to land on Mars. I put my head in that capsule. It's already built. So that's how close we are. We're going to start doing lunar orbiting testing for that Orion capsule in 2022 and possibly in 2021. All right, so does it sound like our current space medicine architecture that I talked about is sufficient to do all that stuff I just talked about? Selecting astronauts, getting them ready, buffing them up, and then sending them out and just talking to them? That's not going to be enough, is it? So, no, it is not. That is not enough. So we got to figure out something else. So how do we change our space medicine architecture? We have to prepare to practice medicine in space, not just to prepare for space. And to do that right now, we're working on 3 strategic lines of effort. So those are 3 things that we're trying to do to support that medicine in space. The first is medical evacuation from Earth orbit. So if somebody gets hurt in orbit, how do we send an ambulance to go get them and bring them back? Or how do we put an ambulance there to then bring them back if they get hurt? The second is strategic patient movement between planetary orbits. So once we figure out how to get those, those people from orbit back to Earth, well, we're going to go beyond there. We're going to the moon. So how do we get them from the moon to Earth? How do we get them from Mars to the moon? We have to figure out how to strategically move those patients. And then third, and most exciting, I'm going to move y'all's pictures up to the top here so I'm not looking off to the side. Third and most exciting is medical and surgical resuscitation on non-terrestrial planetary surfaces. So doing surgery and doing ICU care on the moon, on Mars, and beyond. That's exciting. So you may think that you're saying, Sparky, there's no way we're ever going to do something like that. Well, we are, and let me tell you about how we're going to do it. So let's focus on number 3, medical and surgical resuscitation on non-terrestrial planetary surfaces. So think about the tactical aspect of this. How do we perform surgery on the moon? How do we do it on Mars? How do we get the equipment there? Think about an OR and all the stuff that's inside an operating room. How do we get the equipment? How do we get the supplies there? How do we get the medications there? A pharmacy on the moon. How do we build a facility to do it in? And then what are the tactics? What are the operations that we're going to do to actually open somebody up, fix them, and close them back up? How are we going to do that? So let's talk about equipment first. So think about the size of the rockets that you've seen that have launched satellites. Okay, one satellite is far smaller than all of the equipment that you have in a single OR. So cargo lift to space is at an extreme premium. Getting stuff out of the atmosphere is really difficult to do. And here's the types of equipment we're talking about. An anesthesia machine. Okay, those things are, it's as big as a computer in 1970. Okay, an OR table. We're not just talking about a bed that you sleep in your residence hall. We're talking about a very sophisticated, very heavy bed. Lighting. We have to have really strong lighting to be able to see into the body. Instrumentation, scalpels, forceps, all of the stuff that we use to work inside the body. And then an autoclave to sterilize all that stuff. Okay, how are we going to get that stuff up there? So what's the answer? Do we just take it all with us? Do we take it all to Mars? No, the answer is 3D printing. 3D printing. Okay, so let's go on. All right, so supplies. We've got to have all this stuff that you get, from the cabinets in an OR, that you get, from the cabinets on a hospital ward. Bandages, other consumables. I mean, all of the, plastic syringes, needles, all those things. Surgical sponges and towels, the things that we use to drape the patient, the things we use to soak up the blood inside the body. Patient drapes, the drapes we put over a patient to do surgery to keep everything else sterile. Antiseptics, betadine, that stuff we paint a patient with before we slice them open. And then gowns, masks, gloves, all the PPE that surgical staff wears. So how do we get that stuff there? Answer, 3D printing again. That's the way we're going to do it. Medications. Okay, so think about the pharmacy at Walgreens or CVS. That's about a third of the size of a surgical pharmacy, where you have medications, both oral and IV. You have IV solutions, all the different kinds, saline, D5W, all the different things. And then blood products, packed red blood cells, the ability to draw blood, the ability to freeze it, all of the different blood products to type and cross and match and then administer to a patient that has trauma where they've lost a lot of blood. So what's the answer for this? 3D printing. Yes, really, 3D printing. Would you believe that the Uniformed Services University up in Baltimore in Bethesda, Maryland, has already printed red blood cells on a 3D printer? And those red blood cells are currently being evaluated by the FDA to make sure that they actually function as red blood cells with normal hemoglobin. But it's looking good that they're going to function that way. Think about the difference that could make. No longer would you need to draw blood, have people donate blood. You could just print it, put it on the shelf. When it expires, you disintegrate it, put it back into the slurry, and print it again. You could print it with, you could print O negative blood. You wouldn't have to worry about typing and crossing. Absolutely mind-blowing technology. So those are the medications. So now what about the facility? What do you think the answer is for this? No, it's not 3D printing. Okay, we're not going to print an OR to go on the surface of the moon. But we do have to develop a pressure vessel. So a pressure vessel, if you think about, the moon is essentially zero, it is zero atmosphere. You've got no gas atmosphere there at all. So you've got no pressure on the surface of the moon, no ambient pressure. Well, we have to have pressure. And in order to do medical resuscitation and for patients to heal, that pressure has to be pretty close to what the ambient pressure here is on Earth at 14 psi. Now, in the orbiting space station, the pressure is about 14 to 10 psi, depending on the module you're in. In the space shuttle was 10 psi. In the extravehicular activity suits, the spacewalking suits that astronauts wear, they're at 5 psi. Okay, that is not sufficient for healing of tissues because, as you will remember if you've taken chemistry already, Dalton's gas law, that the sum of the partial pressures of the individual gases in a solution is equal to the total pressure of that solution. So it doesn't matter if you give a patient 100% oxygen, if the pressure it's being given at, if the partial pressure is less than it is at 14 psi. So we have to get a pressure vessel that we can build out that will allow patients to be operated on and heal in normal Earth ambient pressure. But here's the problem. The larger the pressure differential between the outside and the inside, the heavier and more expensive the vessel is. And as I just told you, cargo lift is at an extreme premium. So we got to figure that out. We also need holding capacity for patients to recover after surgery, to recover in an ICU, and then to rehabilitate. Because once we're at Mars, if somebody gets hurt, we need to not have to send them back to Earth. They've got to be able to recover and return to duty there on Mars. So we're going to have to do rehabilitation as well. So let's talk about operations. You need some level of gravity for surgical operations. Because can you imagine opening the abdomen in the OR in 0G? What's going to happen? Guts and blood are going to float everywhere. Okay, so you've got to have something that's going to pull that stuff down and keep it in the abdomen. You don't need full Earth's gravity, you just need some gravity. So the moon is at about 17 to 19% Earth's gravity, and Mars is roughly 1/3 Earth's gravity. And that's enough. That's enough to control that operative field. So we've got to do surgical resuscitation on a planetary surface, not on orbit. So we can't do surgery in the Lunar Gateway orbiter. We can't do it in orbit around Mars. We've got to do it on the surface of a planet. The moon is where we're going to learn how to do this. So that's the first place we're going to do it and practice for when we go to Mars. Then we'll do it on Mars. And that's where we'll perfect it to wherever we go next. And I'm telling you, we're going to go somewhere after Mars. So we also need gravity for normal cardiovascular reflexes and blood flow, and also to prevent bone demineralization. And that's something we've already seen a problem with in our astronauts that are on long-term orbital missions for a year or longer on orbit around the Earth. So after all of that, I know what you're thinking. So what, Doc? What does this mean for me? None of this. I'm not going to do any of this. I'm not going to build a pressure vessel on the moon. What are you talking about? Listen, if you can't find a research topic in everything that I've just talked about, think harder, Homer. Okay, you can find something here that we can research right here at Baylor. How about 3D printing of molecular level pharmacologic structures? How about you and I get into a lab and try to print a penicillin ring on a 3D molecular printer? And then we aggregate that into injectable or oral penicillin. That's going to be done. Why not do it here? How about 3D print production of objects like scalpels or other surgical instruments where you print them in a sterile field. So they're sterile, they don't have to be autoclaved. You use them, and then you figure out a way to disintegrate them and return them to the slurry so it can be used again. Somebody's going to figure that out. Might as well be you. Air quality and human respiration. Okay, I have a mentee that's working on that right now, on artificial surfactant and air quality in long duration space flight. Okay, we're doing that right now here at Baylor. How about, so let's say medicine's not your gig. What about bioengineering? How about engineering a low mass pressure vessel, a strategy to do that? Instead of building it like an aircraft, let's build it like the thing that Matt Damon was in The Martian. Okay, something that has a foil wall. Figure out how to do that. Somebody's going to figure it out. Might as well be you. And new rehab strategies for low gravity environments. You know, if you go to physical therapy, they've got you jumping and squatting and pulling on rubber bands and lifting weights. Well, if you lift weights in 17% Earth's gravity, you got to have a lot of plates on the bar to get the same weight, to get the same effect. So let's figure out new strategies for how we do that rehab. We can do that here. So to sum up, we are going to Mars. Medics are going to be needed on Mars. And the first trauma surgeon, emergency medicine physician, and OR nurse to get deployment orders to Mars are in college today. Is it going to be you? Please say yes. Let's make this happen. You can do this. You can contribute to the greatest adventure that mankind has ever undertaken, putting our feet on another planet and then colonizing that planet. I can't think of anything more exciting. All right, and with that, that's all I've got. So I'm going to turn it back over to Parker.
Dr. Matthews, that was so cool. I hope that someone in this room is one of those people. Okay, well, I have some questions to share, questions to ask for you guys. We have about 22-ish minutes more. If y'all would like to go over a little bit, then whoever wants to stay can. We don't want to we want to be conscious of your time. So we'll go ahead and do that. Okay. Yeah.
All right, so our first question, or it's a question for you, Dr. Pitts, then we'll have one for Dr. Matthews, and then the rest of the slides will be questions that either of you can answer, or both of you. So Dr. Pitts, in regards to your previous research, what led you in that direction, and where did you your research inspiration originate? And now you're so passionate about genetics, so where did that all come from?
Whew, that's a really good question, actually. So I think with undergraduate research, I worked actually on the 16S ribosomal gene, which was interesting. But then when I went to graduate school, when you're in graduate school, you get to rotate in different labs. And I think it's different now. You can actually, one of the reasons I was thinking it would be interesting for you all to go to the Friday seminars is you'll get to know faculty members outside of Baylor, and you can look to see where you might want to go to graduate school, or if you decide to do medical school. I have to say though, anything I would do now would be with Dr. Matthews. So I'm just saying, I would, so you can scratch everything I'm saying and work with the 3D print. I mean, that is just, really, that just totally blew me away. So it makes the lab look a little, but this is the genetics lab stuff is what a lot of people do. So we'll get there. Anyway, so I actually rotated in a few different labs, and it's neat because you can actually pick the mentor that you would like to work with. And that's the way Baylor works. They actually recommend that you do not necessarily go to graduate school where you went to college. And so for me, I actually rotated in a few different labs. Two were actually plant labs because I love, in basic research, generally you work with C. elegans, Arabidopsis, which is a plant, yeast, cyanobacteria. I mean, there are a lot of basic research that you would do because obviously we're not going to work on humans, right? And so everything is done in a basic research. And I was just really interested in, I really liked my advisor and I really liked the hormone auxin. But then I would say I kind of lucked into my postdoctorate where I ended up working with Dr. Honegger with the insect hormone. But I really feel like we can choose where we want to go, but God knows where we're going to go. And so we may have that path that we have in mind, but he has different ideas. And for me, I'll never forget my advisor even saying, oh, I work with insects, but you don't have to touch them if you don't want. And I thought, well, why wouldn't I want to dissect the nervous system out of a cockroach? I mean, how cool is that, right? So one of the main things I did was I would pull like fruit fly, the nervous system out of a fruit fly larva. I mean, how fun is that, right? So I would say my research, I was fortunate in that some of the projects I picked, it is hard to come up with your own project. And so you talk to your advisor and come up with your own. So, and I've worked with a lot of different insects now, including the mosquitoes with my husband. So, but with the genetics lab, it's pretty cool. I love it. I'm definitely where God wants me to be. So I love working with all the students and I recognize some of the names. So.
Okay.
Thank you.
On to the next question. Thank you, Dr. Pitts.
Yeah.
Okay, there we go.
All right, Dr. Matthews. So what would you say are the main similarities and differences between military medicine and civilian medicine?
All right. I tell you what, before I answer that question, I want to show you how science crosses over between disciplines. Okay. So let's talk about Dr. Pitt's genetics lab. So how could that possibly do anything with the space stuff that I just talked about? Well, long duration space flight, exposure to cosmic radiation is a significant problem that we got to figure out because that radiation causes genetic mutation. So if someday somebody's going to figure out how to fortify the genetic structure of chromosomes where they are more resistant to mutation from radiation. And so there's a great track to join those two. And I'll tell you something else that doesn't have to do with space, but something that's going to happen in your lifetime, in your careers, is someone's going to invent the artificial pancreas to cure diabetes mellitus. Okay, and here's the structure that is being worked on right now. So what you have to have for that is you have to have something that assesses the glucose level in the blood real time. You have to have something that produces insulin inside the body. And you have to have a way to store and release that insulin into the blood based on the glucose level. So the glucose flow by sensor, we already have. So I'm sure that you've heard of those sensors that people wear on the back of their arms that give them real-time blood glucose measurements. So we figured that out. So now what we're working on is taking yeast or another single-celled organism that is hardy enough to do it, genetically modifying that to produce insulin. And so the implantable artificial pancreas will have a flow-by glucose monitor. It'll have a tank that has a yeast culture that produces insulin. As that insulin is produced, it will cross a semi-permeable membrane into an insulin holding tank. And then a microcomputer will release that insulin into the bloodstream based on the glucose level that's sensed in the blood. That's going to happen during your scientific careers. Okay, so there's lots of ways to use everything that we're talking about to do just a myriad of things. Okay, now to the question you asked. So here's the thing between military medicine and civilian medicine. Here's a secret. once somebody puts on the uniform and all that cool gear and they go jump out of airplanes or, carry 80-pound rucksack with, with a big cool rifle, the squishy part that's inside the uniform is the same as the squishy parts of people that go to the hospital and to a clinic. Okay, the medicine is the same. People in uniform have the same problems, the same medical problems, the same psychological problems, the same life problems that folks that are not serving in the military do. So the practice of military medicine is remarkably similar. In fact, on most days, if you didn't put funny clothes on to go to work, you wouldn't know that you were practicing military medicine. You're just practicing medicine. You're seeing active duty members, you're seeing their families, you're taking care of them the same way. So probably the significant difference is one, you occasionally get a nice, desert or mountain vacation that you might not have planned on, where you get to go somewhere in the world that you don't really have a choice but to go. But that can be fun too. Actually, that's usually a lot of fun. But the other aspect of this is you see injuries that you might not see in the civilian world. So especially if you go to war, I was a hospital commander in Afghanistan for a year, and we saw injuries that no one else in the world sees. Okay, no one else sees a person that gets hit in the forehead with an RPG round that bounces off and explodes. Okay, nobody else sees that. So you get to see things that other physicians might not see. That's mostly surgeons that are going to see that. But the other difference between military medicine and civilian medicine is in the military, you're taking care of brothers and sisters in arms. So the people that you care for are part of the same family with the same mission that you have. And so it binds you together in a way that civilian doctors just don't get a chance to do. And so it's really, really rewarding to take care of people that have the same mission in life that you do. There's just something, it's hard to put your finger on what that is. Now, military medicine also has some disciplines that civilian medicine doesn't have. It's really hard to be an aerospace medicine specialist in the civilian world. You can do it, but it's not easy to do. But if you are an aerospace medicine specialist in the civilian world, you don't get to do the kind of things that I got to do, which is do high mountain rescue and helicopters up in Washington State, or fly in the back of an F-16 in combat, or go push parajumpers off the back of the ramp of a C-130. That you get to do some really, really cool things that you wouldn't get to do in the civilian world. That's not for everybody, but if it's for you, nothing else is like it. So hope that answered the question. That's probably the best I can do.
Yes, thank you. For these questions, they're for both of you, and you can pick one, or if you want to answer both, you can say something about each. So the first one is, do you have any significant highs or lows from your journey through your career that have significantly shaped who you are? And then other question is, what brought you to your current path? When did this occur? And why did you want to pursue this path over other opportunities?
I pretty much answered the second one. I will say I truly think it's a God thing that I'm here now, because I absolutely love what I'm doing, and I don't think everybody loves their jobs. I love being at Baylor. I mean, there's nothing like being at a Christian university. I really enjoyed being at Vanderbilt University, but I love being at Baylor University. And I love being the genetics lab coordinator. It's really fun. Other than having to give students grades, it's really fun. That's sometimes a little tough. I would say I guess I talked a little bit about highs and lows as well. I had a rough time in graduate school. I enjoyed it. I really liked my mentor as a person, but he was kind of a sink or swim, whereas he did not give a lot of guidance. I worked on so my experiment, so what I did was we worked with auxin, and auxin is transported from the apical meristem down to from the top to the bottom. And I really wanted to make a mutant. And the first 2 years I spent characterizing a mutant, but it turned out that mutation was due to the transformation process. And my boss didn't really pay attention and I didn't know what I was doing. And so I spent 2 years on a project that really just went bust. And we finally did get the mutant and it was so cool. It was really fun, but I still didn't get a lot of guidance. So I would say when you do have a mentor, make them, I don't know, try to stay in more contact. So that was tough. But I've had a lot of good support in my life. My husband and I were actually in the same lab, so he had the same experience I did. So that was kind of fun. Go ahead.
All right. Dr. Pitts, I have to say that I have never done anything as cool in my whole life as to be able to say I made a mutant. That's that's pretty cool. Okay, so as far as significant highs or lows in my journey, so one of my biggest highs in this journey was having Dr. Bill Hillis as my mentor here at Baylor. He literally changed the course of my life in showing me a path into the Air Force. Aside from that, I got to tell you, not a whole lot of lows. I've had a lot of highs because I've just had a ball everywhere I've been. There's no such thing as a bad assignment. Okay, it's life is what you make of it. It's finding the joy in everything that you do. So if I had lows, I've had some tough bosses, but I'll tell you that you learn more from bad leadership than you do from good leadership. And I've had a lot of good instructors, let me put it that way. So some of the other lows, though, I've seen some difficult things in Afghanistan and Iraq. I've looked death in the lips a couple of times, flying air ambulance out into the desert. Those are both lows and highs because it's exciting to look back on, but it wasn't a lot of fun when it happened. Okay, so on to the second question. So what brought me to my current path? A student asked me in my seminar last semester, if I wrote my autobiography, what would the title be? The title would be, God gave me what I wanted instead of what I asked for. And God has taken me to a place and through a path that's really been the long way home to Baylor. To a certain extent, I think that my 28 years in the Air Force was just to prepare me to come back and be here for you and help you become who you want to be. So, that path has been long and winding. My path in the Air Force ended, like I said, about 2 years ago when I made the decision to retire. I had people that I was one of the service surgeons general, first surgeon general of the Space Force. I had friends that said, "Why are you leaving now? You have a shot at being a general. Why would you leave?" And I said, "I can't explain it other than God is telling me that this is where I'm supposed to be, back here at Baylor." Now, I wanted to come back and teach at Baylor and be Bill Hillis for a new generation since before I graduated. So I knew this is always where I wanted to come back. But the opportunity presented itself, and probably the most significant high I've ever had in my life was January 17th of 2020, when Dr. Elizabeth Corey sent me the email that said, "We've decided to offer you an appointment in the Honors College." Doesn't get much better than that. I'm coming home to Baylor. And so now I'm here. And for the last year, I've had so much fun. I can't believe they pay me to do this. It's so much fun. And I can honestly say that I'm the happiest I have ever been in my entire life, doing what I'm doing right now. I mean, it's almost 7 o'clock and I had to look at the clock to see. I'm having that much fun. So why did I want to pursue this path over other opportunities? A lot of physicians don't understand why I would rather teach than practice, than be in clinical practice. But the way I look at it, and granted, I have a very focused view on pre-med students, to a smaller extent pre-health students, but people that want to be doctors. So every pre-med student that I help get into medical school and become a doctor, every single patient that they ever help, that they ever see, I have a part of that. And so I can make such a greater impact by doing this than I could taking care of patients in a clinic. So that's why I do what I do. And that's why I pursue this over other opportunities. All righty.
All right, Dr. Pitts, Dr. Matthews, I'd like to extend, before I begin this, I'd like to extend my thanks, as long as the thanks of all the members that are here today. You have really inspired all of us. You've talked about your journeys. I know it spoke to me very personally. Sometimes it's good to just back up and see that, we are all working for the bigger picture, that in this time of information overload and finals, we're kind of going towards this one point, but it's very important to back up and, to see that we're working for the rest of humanity and for each other. And that is ultimately what's very important. So thank you on my behalf, on behalf of Burst. And let's move on here. So I guess the question I would like to extend to both of you, and I'm just going to combine these two for the sake of time, is for us undergrads who have our whole journey ahead of us. And, we've seen a lot, but there's still a long way to go. What do we focus on in our free time, apart from research and shadowing, apart from specific, professional experience? What are other things that you suggest we focus on, or we gain experience in, that will, help us move forward from here?
If you want the honest truth, fun. What Dr. Matthews said about enjoying, and I'm glad that Dr. Matthews got this early on, but I didn't learn this until I was older, that, even though it's so stressful right now, have fun in what you're doing. Enjoy every moment, because it's true, though, for those who have had COVID, you don't know what you have until you don't, right? I mean, my gosh, am I blessed? Do I wake up every day feeling happy? No, it's kind of like Groundhog's Day, honestly. I wake up every morning and I go, ugh. And then I have my coffee and I'm like, woo, I'm ready to conquer the world. And, I enjoy, let me tell you one really quick story. When January 1st, I decided I'm going to, because it's really hard to work full time and, parent, and it's a challenge. I was like, I'm going to cook for my family. And I looked up, I love Asian chicken lettuce wraps. Okay. So I went to the store January 1st. I was driving home. I was like, yes, this is so cool. I forgot the lettuce. I am making Asian chicken lettuce wraps and I forgot the lettuce. But I live towards McGregor and God gave me the most beautiful sunset. And so I thought, you know what? We're just going to have rice. And it was delicious. They are good. Yes, Joyce. They are they are absolutely amazing. And you don't have to have the lettuce. That's really good. But that's the kind of thing that, honest to God, that happens in my life every single day. And I really think if you pray for things to happen, they happen. Like for me, I ask God to give me a little treasure every day, and he'll give me an insect or something fun, or my cat will greet us, but I think in the summer, it is really important to do something towards school, but also have fun. I worked for 2 summers. One summer I did a fellowship at I fellowship at our hospital, and I waitressed. But the next 2 summers, I quit my job and I went up to Mackinac Island. I don't know if you've ever heard of it. It's in northern Michigan. It's 8 miles around, has no cars. And I worked as a breakfast cook and as a grill cook in the afternoon. And one summer it was a baker. I had the time of my life. It was amazing. So I think don't put so much stress on yourselves. And if you decide to change from what you're doing and do business, maybe some of you are business, so what? You're young, okay? People our age, Dr. Matthews and mine, still don't know what they want to do half the time. He and I are so blessed that we are doing exactly what we want to do. So, okay, good.
So I have to say to what Dr. Pitts said, I just finally figured out what I want to be when I grow up. Okay. And my children are older than all of you students. Okay. So I just figured it out. Not really. But so what do I feel is, you know what? Let me start by giving you 2 scripture verses. Okay. And they've been life verses for me. One of them, I don't remember the reference. I believe it's in Galatians, it may be Ephesians. But it's when Paul says, for it's God that works within us to will and to act according to his good purpose. And what that says to me is that it's God that works in us to will according to his good purpose. the desires of our heart that we have inside us, the deepest things that we want to do. For a believer, God has placed those desires in your heart for the sole purpose of fulfilling them. Okay, that's that God works within us to will and to act according to his good purpose. So what it is that's the desire of your heart, work towards that and move towards it. And the second verse is one of my favorite verses in all the Bible. And it's Proverbs 22:29 that says, do you see a man who is skilled in his work? He will serve before kings. He will not serve before common men. And what that tells me is that my job, my responsibility is to do the best job I can in the job I have today. And God will take care of placing me where he wants me to serve. And that I don't need to worry about the next job, that next promotion, that next thing. I just got to be the best at what I'm doing today. And then God will take care of the rest. So speaking specifically to the questions. So, and I'm going to speak to pre-health and specifically pre-med students here. And I'm sorry if that's not everybody here, but this is what I know, okay? For a pre-med student, I recommend that every pre-health, every pre-med student during some summer get certified as an emergency medical technician. Okay, EMT certification. When I applied to medical school, that's the one thing that every single interviewer at every single medical school said something positive about, because they said, hey, you know what you're getting yourself into, and that shows commitment because you've done the job. So here's the thing, EMT certification, it's adult education at any community college. You can do it anywhere. MCC does it here in Waco. It's easy and it is so much fun. Part of your job is working in a hospital emergency room and riding out on an ambulance and doing the job as an emergency medical technician. It is a blast. And here's the thing, if you don't like that, if you don't like messing around with patients, better to find out early than later, because then you need to decide, well, maybe I need to do something else besides medical school. Okay. But EMT certification is a great idea. It's quick. It's easy. You can do it in the summer while you're doing another job. You can do night classes. It's really easy to do. But I agree with Dr. Pitts. During the summer, you got to let this noggin cool down a little bit. Okay. So, and here's the other thing. If you have aspirations of driving forward and pushing through and graduating early, graduating in 3 years, if that's a financial consideration for you, I get it. And you got to do what you got to do. But if you're doing it because you just want to get to that next thing, oh, for goodness sake, please listen to the voice of wisdom and experience and don't do that. Because if you're going to take the MCAT, if you're going to take the GRE, if you pack all of those really difficult classes into single semesters as you go, and don't meter them out as you go, and add in some French and some Spanish and some theater appreciation and some badminton and all of those other things, you're going to burn yourself out and you're going to burn yourself up. And you're not going to do well in all those courses. Okay, it's hard to do everything well when everything is hard. So give yourself the time, do a 4-year course of study, have fun while you're here. My goodness, have fun. Baylor is so much fun. I came back, okay? This is the most amazing 4 years you're going to have in your whole life, because you do things here with almost no cost, okay? So have fun while you're here. Study hard, work hard, but have fun, okay? Don't try to compress it all into one neat little package, okay? All right, so that's what I got.
All right, thank you very much. And then Parker, if you don't mind moving on.
Yeah. So right now we are a little bit over time. We just want to be cognizant of your time, and just knowing that this meeting is supposed to run from 6:30 to 7:30. We really appreciate you telling all these stories, Dr. Pitts and Dr. Matthews. It's definitely inspiring, and getting to hear from you guys in that manner. So for whoever needs to leave, I put the Google form in the chat, and we can call it now. If Dr. Pitts and Dr. Matthews would like to continue to answer these questions, you can, but just giving you that option now.
So Parker, I just have a few more minutes because I still have neuropathophysiology slides to finish for tomorrow.
Yeah, that sounds great.
I will
And
say I have plenty of time, but I have to say one thing. I just have to get this out there. I have a student who got his EMT right before he finished high school, and he gives vaccines over at the SLIC. How cool is that? And you know what, Dr. Matthews, I might go get certified because that is just amazing. And I also have to give one more quick plug. The Baylor Marina is phenomenal. If you have not been there to paddleboard or kayak, and that Baylor rock over in the SLIC, go climb it. Have fun, do some outdoor stuff. Go ahead.
Yeah, the marina is a great date
incredible.
location. My wife and I, my wife now, my girlfriend then, she and I went sailing quite a few times. And yeah, when the sun's getting low on the Brazos and it's a sunset and you're out in a sailboat, that's a great time to sneak a kiss. Okay, so that's a great location.
That's
I didn't say
cool.
that. I'm sorry. That was my outside voice.
That's very adorable. Thank you both so much. I just had one last question for Dr. Pitts. I know you're the genetics lab coordinator. Do you know if they're still hosting the cure research for genetics for sophomores next year?
That is a very good question. I will ask Dr. Minke and I will let you know. I know that she and Dr. Abel did it was it this past fall? I don't know. It must have been
like 2 years ago now.
Yeah, 2 years ago. I don't know. So I will find out for you. I'll ask. Are you interested? Or is it, do you know?
I was actually in their first year when they tried.
You were?
Yeah.
I keep telling them, you guys need to come pick up your notebooks. I mean, what a treasure. You're welcome to come into the lab sometime and pick it up. They're in the cubby holes.
Okay, that'd be awesome. Thank you.
Oh, I think everybody should keep their lab manual, their little notebooks. So I'm willing to stay if anybody. I don't have slides tomorrow. I have we have an exam on, but it's not until Monday.
So let me say about those lab notebooks. I still have my lab notebooks from Baylor when I was a student, and I was looking through my genetics lab notebook a couple of years ago.
Really?
And was amazed at the notes I was taking on this theoretical structure that we thought in some of the advanced genetics labs we were going to be able to create, called the plasmid. Okay, so it's been a while.
Well, I would love to see that. The history. I try to teach students the history behind all of it because it's amazing.
I'll see if I can find it. It's still in a box somewhere in the garage.
Well, here's the sad truth. When you do a PhD, your lab notebooks stay in the lab. And once everything's published, after so many years, they throw them away. So it's very sad. I have my dissertation, but.
So imagine if Freud and Jung had their notebooks thrown away. I mean,
I know. Think about. So the things we could talk about.
Absolutely. All right. Well, hey, listen, folks, I'm going to have to sign off. I'll leave you with Dr. Pitts. She's got a lot more to talk about research than I do. I just have good ideas.
Oh, you're amazing.
Do anything with them.
I mean, 3D printing of red blood cells and yeah.
So give me a little while and we'll get something like that started here and we'll figure it out.
That's incredible.
Thank you so much, Dr. Matthews.
Thank y'all very much. Y'all take care.
Bye, Dr. Matthews.
Thank you, Dr. Matthews.
I can